I would say I'll start with announcements and then we'll start this event. First announcement: the contest is ongoing. Currently, the contest will be ending December 31st. So, if anybody here, I think most of people I see here are part of the contest and have queries to submit, go ahead and submit them. Um, Other than that, we know that a lot of you guys have been submitting a lot of submissions, which has been fantastic. And we are trying to respond as quickly as we can. I appreciate all the people who are reaching out to me over DMs asking for um, questions and feedback, etc. Please continue doing that. Also, know that your query will be responded to. We will give you feedback, we promise. For any queries that maybe don't have a response in a timely fashion, as long as the query is submitted before the contest ends, we consider it a valid query, even if there's follow up feedback. So don't worry too much if your query will not be approved by the end of the contest. Even if it's approved after the contest, we still count it. It just for us, it just matters whether or not you submit the query or contribution before the contest ends. So I think those are the really big updates. Again, I just want to emphasize we're going through every single query submission. Some of them are really great. We really appreciate the time you guys take out to work on them, and we hope that we can get to all of them as soon as we can. So just thank you, thank you, thank you for your patience. Okay, let's get started. Welcome, everybody, to another Discord event here at Remedy. Today, we're going to talk about glider tips, how to write specifically better queries that reduce that lead to a reduction in the feedback time it takes between you and the triager, and hopefully show you some ways that we could write queries that can return a higher true positive rate, which is something we really care about, and find vulnerabilities on chain. So, how this is going to work is I'm going to have some code examples for you guys. These are all code examples I wrote from scratch, and we're going to talk about the good, bad, and ugly of each one of them. And I think everything that we're going to be talking about today is something I see almost on a daily basis. So maybe this is going to impact you in your queries, maybe not. But regardless, I think this is all really good information for you guys to take into consideration, because if you follow all the steps here, you will certainly write better queries and also uh, make it easier for us to approve your query faster. So I'm going to go ahead and share my screen. If you give me 1 second, guys. Uh, Trying to find. I think this is it. Yeah, this is it. So hopefully everybody can see my screen. And if you have questions, by the way, while we're talking through, Alan, you could just stop me at any time and just ask me the question. And ask that question in chat too, and Ellen will see it. So the first example I want to give, and I'm going to have several examples of this, is grepping. We see grepping a lot. We've relaxed the rules on grepping, and I want to be very clear about what those grepping rules exactly are. And I want to emphasize this to be very clear. Grepping is allowed as long as the query returns an extraordinarily high true positive rate. And what that means is that when we run the query, almost every single hit is a true positive. Uh, Most oftentimes, when grepping is used, that does not occur. Grepping is it's fragile, and I could talk about why it's fragile. But more importantly, oftentimes than not, grepping has side effects that I think sometimes people don't think or take into account with static code analysis queries like Glider. So, this first example, we have a case where a user just wants to find vaults, and what they're doing here, we're going to look at this query in particular. What we're doing here is looking for contracts that are neither either named Vault or Token Vault. And I'm like on maybe on a surface level that makes sense, but we're making an assumption about how a developer names a vault. And this is something that's a big problem with grepping is we make assumptions about how developers are naming variables, naming contracts, functions. That is going to lead you down to a path of where your query is not going to be able to catch every case. And it's very important to catch almost, I mean, it's not going to always be 100%, but it should try to catch every case possible. This helps you find bug bounties. This also helps write a better query so that, let's say, down the road when a contract is deployed and it works a little bit different than how other, it's named differently, how than compared to how other developers name, say, their contracts. Your query will be able to find this. If you use grepping, you restrict how powerful that query can be. So this is a case where we would really prefer if you instead thought about conventions or like standard practices in Solidity projects. So in this case, what we have is instead of trying to come up with a list of contract names, we think about the 4626 standard. And for example, Open Zeppelin has a contract called IERC 4626, which we think most developers will use, and we inherit to that. Will we miss results with this query? Yes. But my argument is that if you're writing this type of query, you're obviously going to be targeting 4626 contracts. I don't think it, I don't think there's many queries out there where you could query a vault contract, which is we could take it as an abstract term and then find the vulnerability. I see you guys write it, and it's really cool to see. But I think it makes it much harder to find results when we try to treat this as this sort of grepping abstract query. Whereas here, we've clearly defined expectations and standards. We know that many contracts use Open Zeppelin. It's a standard. And most often than not, they will have this interface contract that's inherited into their main contract. Here's another example I see often. This is kind of using the same query as above, but here we have a case where a query is looking for calls, and it does so by grepping the source code. I see this quite often. I see interesting variations of this. In general, we have a Glider API library documentation, which at the end of the call we'll share. We'll share this and any other links we talk about. Um, but we have a Glider API library, and we could actually just use the Glider API library to find these these calls that are made in the source code. I don't know if it's hard for me to know where this is coming from, but you guys are always really welcome to ask us on Discord if you have questions about how the Glider API library documentation works. Hey, I want to find this function call inside a function. We're more than happy to help you answer those questions. Documentation also provides examples, and if you just browse through the documentation a little bit, you'll be able to find that. So, um, in cases like this, we actually have. There's a couple ways we could do it, but the way I decided to do it for this query, and not to say this is a de facto way, is we could actually just query the function for instructions, and um, we have a designated function called low level external calls, and so we can just call that. Just as a side note, we are also going to talk about legendary queries. I have some discussion on that, but I want to get through this first. I just want to remind everybody about that in case I don't forget as well. Um, Here's another example of grepping. In this case, we're just the intention of the query is to look for functions called swap, and on like a basic level, that can make sense. Let's say you're trying to find a vulnerability that deals with swap functions, and swap functions is an abstract term, is treated abstractly by you, the contributor. Um, most often, this is going to return a lot of false positives. This type of query is going to return functions that do all sorts of types of swaps. And I think oftentimes, let's think about this particular vulnerability in general. If we're looking for a function that does swapping, we actually want to look for how that function works, not just the naming. I mean, developers can name their functions anything. And as mentioned in the first example, I think it's somewhat dangerous to assume you know how a developer is going to name a a function, a contract, variable, etc. So I think a better approach to this is to actually just check to see if the swap function that we're looking for is calling another function, is doing something that would be a standard practice for a swap function. So in this example, what I've done is I'm looking for this function that comes from Uniswap v2. It's called swap exact ETH for tokens. And obviously, this is just an example I made up. But what I'm doing here is I'm looking for functions that call another function that is a pattern of swap functions. So I'm not looking for to see if what the function is called. I don't care what the function is called. I just care if it uses this particular function. That tells me if it's actually doing swapping. That's what I think is more important than looking for the names. I'm going to pause right here. Ellen, do we have any questions so far?
No, we don't.
Okay. In this next example, I think this is going to be the final grepping example. Um, so in this case, what I have seen is uh, borrowing from the previous example, we're looking for functions named swap, which I know I've talked about is not a good idea, but this is just an example. So bear with me. Here we are grepping for a function that uses a mapping. And I'm being somewhat abstract in this query and saying, well, I don't know what the mapping is named. Maybe it's named balances, maybe it's named balance, user tokens, tokens. When something like this is going on, there's a couple of issues that's happening. Obviously, again, you're making the assumption that you know what the mapping name is, and that is somewhat questionable. But more importantly, you're relying on um, how the code how the code is designed. So let's say there is a. I'll just write a comment here. Let's just say there's a mapping named let's say staking balances. Well, according to this query, this portion of the query, it's going to return staking balances, which is probably not what you want. But because you're grepping the source code in a very liberal fashion, it's going to pick it up because in this first condition, it's going to say, well, does this code exist inside the function source code? Yes, it does. So it's going to return it. This is this is going to return a lot of false positives for you, and it's going to make it hard to identify contracts that have maybe a different naming from balance. Um, and this is a really tricky query to write because in this case, maybe you don't know what the mapping is called. So there's a couple solutions. The solution I'm going to show you uh, is making an assumption that well, we're just going to look for balances. And not only that, we're going to use this function that exists in our glider cheat sheet. I think I've probably shared it with many contributors. It's called get components recursive, and it's going to find every component in a particular instruction. So what I'm doing here is I'm going through the function, going through the instructions, getting every component for every instruction, and just checking to see if the term balances is inside the component expression. We could probably even go further and just make this an equal operation. So we're still actually, I mean, technically we're still doing grepping here, but what's happening is that we are being very, very specific about what we are grepping. We are grepping a individual component. And when we do that, uh, we're able to get a higher true positive rate. As I mentioned earlier in this query, that if we have a mapping called staking balances, and we have a query run against this contract that was staking balances, it's going to return staking balances. Here, it's not going to do that. So we are grepping with intent purpose. So in all the previous examples, we've treated grepping as this very abstract thing. It could mean many things. It's based on what our interpretation of the code. Here, we're being more precise about what we're grepping. We've broken down
Jason,
the yes, go ahead.
Jason, I'm sorry. I think some people don't see your screen. Can you
Oh, they
restart?
don't.
Some people
Oh,
don't.
some
I,
people don't.
I, yes, I don't know how that happened, but maybe you
I
can
would say,
restart.
are they on maybe mobile? Is that maybe?
Um,
Let me.
are
I'll,
you
I could.
guys
I could.
on
I could.
mobile?
I
I
could.
don't
I
think
could.
so.
So I would say Discord is telling me my screen share, but I'll stop and restart it. Let's see if
Please.
that works. And obviously, if you guys, I'll also share the file that I have with me. So if you guys want to just look at that code again that I'm showing on screen, I'm more than happy to do that. How about now? Hopefully, you guys can see my screen. Okay. It sounds like some people can, some people can't.
Nice.
Okay. Here's what I would say.
Uh-huh.
If you guys,
Okay.
if, really sorry about that. I will, for the people who maybe haven't seen it, I'll go over this particular example. But as I discussed previously, each example that I have, you could just look in the file, and I'll share the file with you guys after this call. But in this example, example number 4, I'm just briefly showing you this query that will grep for particular mappings inside a function source code. And so in this particular case, we've just have different names for different mappings. And this is actually, I think, a somewhat poor solution, again, because we're making assumptions about how the developer is writing code, and it results in us returning false positives, which we could certainly prevent. There's a couple ways we could prevent this. And this solution I have that I've highlighted, what we're doing is we're just using the get components recursive function, which exists in our glider cheat sheet, going through the instructions components and checking to see if a particular component expression equals balances. Now, I've also made the assumption that balances comes from ERC20 tokens, which is a very common. Uh, it's a very, I mean, it's one of the most common names you'll see in any sort of token contract. And let's just say you say, "Hey, Jason, I actually don't know if it's named balances, and I can't make that assumption." That's okay. What I would typically suggest, and obviously this takes more work, is you can actually iterate through the different contract state variables, and like simple as just doing something like this. Or let's just say you have the contract, you could go through the different state variables, and you could identify if the state variable has a particular type, and maybe that could clue you in on the mappings. And then from there, maybe you could collect the different state variable names, and then you could check to see if it matches the component expression. That's another way of not using grepping, but still checking to see if this function may possibly be using some sort of balance map. And if you have a good idea of how that balance map works, like if you know the key is an address and the value is a uint 256, you could filter out those state variables, get that state variable name, and that's really nice because you're not relying on any grepping whatsoever. Okay, so example 5 here, we're going to be checking where variables flow. And so I see this often in a lot of vulnerabilities. This is not exclusive to, in this example, this is a sort of Oracle price. I'm sure there's some contract that uses get price, but I wasn't particular to any Oracle or um, that matter. Here, what we're doing is we're just going through and finding get price calls and instructions. And then what I'm doing is grepping for a require or an assert. So there's a couple issues here. First is if this query's intention is to identify Oracle spot prices, which is what it's doing, is trying to do that. It's making a couple assumptions about the contents of the function, and I think it's going to lead to a lot of false positives. First, we're not checking to see if get price is used anywhere inside the function. That's problem number one. But problem number two is we are making abstract assumptions that this require or assert must be checking the price, when in reality, it may not. It may be checking something else. It can maybe checking who's calling it. So the way this query is structured is it's not checking to see what the price is, if it's used anywhere, and it's not really checking efficiently if that price is validated. And this, I think, could be easily solved by using something we call data flow. And I've talked a little bit about data flow. And again, I'll be sharing this file. So if you guys look at this and say, "Hey, I want to implement this in my own query," I'll share it with you. You guys could use it. Totally fine with me. Here we're doing things a bit differently. I've used a lot of this information from the Glider API library documentation, which you could just go look at. And what we're doing is we're just going through each instruction, and then we are collecting all of the instructions from the function. That's not just the instructions inside the function, but it's also instructions inside other functions that that function calls. So it's very expensive. It's going to cover every instruction that is called when that function is called. And what we're going to do is we're going to use this very nifty function called callee names. So if we're going to iterate through every instruction, and if it has a callee name, require or assert, then we assume it's true, and then we could assume it's a true positive. So how is this any different from the previous query I showed? Well, first of all, and this is probably most important. Um, we actually, what's actually very funny? There is a mistake in this. Um, Instead of using instructions recursive, we should use. Okay, here's we should do this. We should get. This is going to be uh, very similar destination, and I'll show you guys what I'm doing in a second. I'm just going to for df recursive, and then uh, if is instance. Um, okay, so what I'm doing here is I'm going to get the instruction that contains the get price, and I want to get call this function called getDest. And what this is going to do is we're going to do the return values of the get price, which is what we really care about, right? We're trying to see if this price is used anywhere, if there's any validations against it. Well, what I could do then is using getDest, I could then call for df recursive. And what that's going to do is it's going to find out where price is being used. This is a really powerful Glider API library function that I recommend everybody check out. I see a lot of queries that can use this but don't, and instead they rely on maybe not this simple of grepping, but they will use in some form or variation of this. So just using the Glider API documentation, we can use this for df recursive, and then we iterate through every single. We wouldn't call them instructions. I'll just call them data flow. So data flows. and we go through every single data flow, and we could first check to see like if this data flow is instruction, because sometimes it's not. Sometimes the price will just flow into something that glider will not treat as an instruction, will treat as something else. So we're just validating that the data flow is an instruction. And then we could call these calling names, which is available in instructions. Check to see if there's a sort required. This is, I mean, pretty simple once you get the hang of for DF recursive, but it's very powerful because you could take this example and just use it anywhere. And any sort of vulnerability where you have a function, it's returning something, and you need to check maybe where that return value is going, or maybe to see if there's a require or assert done against that value. So really check this out. Again, I'll share it with you guys after this call. Um, okay, so in this example, this is probably one of the most common things I see in queries from many people, and I think this is actually just I assume it's probably from LLMs. But what's happening here is that we have a query that is just checking to see if there is a low level call made and what that value is. I mean, if you guys know in low level calls, you could optionally pass in a value that represents how much ETH you want to send in that call. So this query is just trying to look for that. And so um, here, uh, what we're going to do is we're going to first go through, get all the 100 low level calls. Then we'll get the actual low level call by calling get value, which is an instruction function, again, in the Glider API documentation. And then we're doing something that I think is somewhat egregious and dangerous, because what we're doing is first we're doing a try accept. And I think there's very rare cases where we use try accept. I think it's used once in our Glider cheat sheet. And that's mainly due to a Glider API limitation. But other than that, oftentimes try accepts hide broken code, because if you write broken code, it will just catch it and then it will continue or it will pass. And so this is one of the most common broken code I see in Glider, and that's not necessarily anybody's fault. Has attribute in particular is not available in Glider queries. Python inside Glider is sandboxed, and so many native functions that you typically see in Python code is not there, including has attribute. So if you call this, it's going to raise an error every single time, and I see it a lot. It's going to hide results. It's going to make your query weaker because you think this functionality is going to work, but it doesn't. You could run the glider query, everything seems fine. So I really want to push against people using try except unless there's a really great reason. I think some people use it to catch memory errors, and that is a very understandable issue. Memory errors, we are okay with. We don't we're okay if your query produces a memory error, and if you do get a memory error, just try to reduce that exact value. That's probably the biggest piece of advice I could give you, or use custom scope. So how do you fix this? It's again pretty simple. The easiest way to do this is you need to understand what the value is in your glider query. In this case, we have this low level call, and I'm just going to call is instance. This function is available to us, and it just checks to see if it's a call. And if it does, then we could call this get call value, which is only callable against calls. I know this will never raise an exception, and I'm guaranteed that this code will work uh, because I have this. I'm validating that's a call, and then I'm calling the get call value. And if it's something else, it's just going to continue. So I don't need try except at all. I'm not calling any functions that don't exist. Um, I will add one more thing too. This is another common thing that I see that people trip up on. We cannot do this in Glider. That's not possible. What we can do, or I'm sorry, we cannot do, I showed you the correct version. We cannot do this. So if your query is doing some sort of uh, addition operation like this, you actually just need to do that. That's a common one. That's kind of tricky because it will raise an error, but you're not be sure why. So just always use this addition operation instead of the addition equals operation in Python, or you'll raise an error. I think we have one more, and then I'll just have some miscellaneous tips for you guys if we don't have any questions. This is another example I see, and this is somewhat related to grepping, but it's more a problem with the query itself. I see some queries which are very ambitious, and like I really appreciate those queries because I know there's a ton of work that's put into it. But the ambitious queries typically do check for many things, and I'm going to be honest with you guys, you don't need to do that. If you're more than welcome to in the query, we're not going to deny it based off of it doing multiple things, but a query that just looks for one vulnerability is good enough for us. We don't have an expectation for it to look for multiple similar vulnerabilities. So, what often I see is a query that will collect a bunch of different contracts. I mean, we talked about grepping, so I'll just ignore that. But it's trying to be ambitious and identify a vulnerability that could exist in many different type of contract types, and then try to leverage some sort of feature that exists in all of these different contracts. And I think typically it becomes a mess. um, Certainly a query should look for every contract available, and if it identifies certain markers, certain traits, then the query should try to look for a vulnerability there. But when you're making assumptions about, well, I think all governor contracts can do this, so I'm going to do this with the name regex and look for it that way. I think that's somewhat dangerous. I think it's going to really limit your query. It's going to limit you from finding bug bounties. It's going to force you to write the query a certain way, which is, uh, I think it's just going to be more problematic down the road, especially if you want to make changes to it. So I would really try to avoid trying to do these really big scope queries. You don't need to do them. I've seen some queries that are probably less than 20 lines that are really great. They do really great things. And so the solution in this case was just to, I mean, I wrote like, you're just going to check for interface contract, see if a contract inherits this iGovernor contract, which comes from Open Zeppelin. Again, a uh, very common contract you see throughout many chains. So I think it's a really good testament for you to check to see if there's a very popular framework and run against that. It's not going to catch those edge cases where maybe they aren't using iGovernor. And so maybe if you want, in that case, you want to have a different way to identify. Maybe you want to look for if the contract has different function names. I think that's also valuable as well. So be very specific about your scope. Don't feel overwhelmed like you need to have your query look for many different things based on semantics. I think that's a bit dangerous, and it's just going to take a lot of work to triage that, especially when there's more code, there's typically more work triaging. I think very rarely have I seen the opposite of that. So I just want to give you guys a couple miscellaneous other tips, and then we'll talk about legendary queries. So for miscellaneous tips, the first thing is duplicate queries. Check the query database to see if your query has been written. Uh, if it has, it's going to be treated as an optimization query, which I suspect some people may not like, especially when they think it's an original, unique query. Or if you want, you could come ask us. You could DM me and we could check for you. That's not too hard to do, especially if the query is currently in triage, because we know that you guys can't access those in progress triage queries. We're trying to work on a solution for that, but in the meantime, just reach out to us and we can answer that. I want to save you guys as much time as possible. I hate that you guys have to work on a query that you think is unique and then you find out it's not. It breaks my heart. For every single query you submit, although I have not shown it in these examples above, please make sure that the results come from main contracts. And if you've had a contribution with us before, I'm sure we've told you how to do that. But if you have any questions, come ask us on Discord. It's typically just one line of code that's needed to identify main contracts. It's almost always needed for every query. There's maybe rare exceptions. I haven't seen those yet. LLMs, obviously, you guys are using AI. There's nothing wrong with it. We're open, we support it. But one thing I have noticed is that when I give feedback to to contributors, and then that feedback is used to edit the query, AI will sometimes change other parts of code that don't need to be changed and actually makes the query worse. So I would be very, very cautious of using AI when editing your queries. Um, or certainly be careful about what AI is changing because it could change code that just doesn't need to be changed, and it's really unfortunate when I see that happen. So just be very cautious of LLMs when editing queries. When it writes queries, it's a hit or miss sometimes, and I would be uh, I would be at least aware of what other queries we've approved and what other queries exist in the query database and kind of reference that if you're going to have an AI write your query from scratch. I think it's okay in the beginning, but you also need to know how Glider API library works because if AI is just producing, if it's just graphing everything, we're going to give you feedback on it and ask you to change it, um, unless there's a very high true positive rate. But that's rare in grepping. It's rare. We have one query that does a lot of grepping and is actually approved. I'll find that query and share it with you guys, but I generally discourage grepping in general. Um, One final thing too is whenever we do ask for edits, um, we ask that you also run the code real quick because sometimes I've seen where an edit will be made and then you won't run it, and then we'll run it in the back end and it will fail. So just be careful of that. You know, it doesn't have to run for 10 minutes. We just have to know that the query succeeded. So you can limit that exec to just one value and leave it at that. Okay, so legendary queries. So I want to give some more feedback and suggestions on finding legendary queries, how to write them, what are sort of the guidance rules that we're looking for. Legendary queries are very special queries in that they are able to find a significant risk for an existing protocol. And that's typically I don't think we have a strong number in our head of what that is. I mean, if I could give you very clear examples, I could say if you know if it's you're saving a protocol 100 $200,000 at risk. That's a certainly a legendary query. That is the primary requirement to be considered a legendary query. So when you're writing your own queries, you just want to be very uh, willing to understand that the query that the vulnerability you're looking for should identify significant risk, significant loss of money, and so not all vulnerabilities I think cover that. Unfortunately, I think it's because it's maybe the vulnerability is so rare, or maybe the vulnerability itself just reduce. You know, it causes something like denial of service. In most contracts, a temporary denial of service is not a significant risk. A permanent denial of service is. That's one example. Another thing you want to think about too with legendary queries is that when you write a legendary query, I think most oftentimes than not you can't grep it. So Don't don't try to grep legendary queries. I don't think you're going to find great results. If anybody has access to ETH recent, maybe some of you guys don't. But if you do, please just use that. I think you'll have a greater chance of finding a legendary query in the ETH recent chain versus ETH mainnet, because ETH recent is going to deal with contracts that are most recent. Um, One other thing you want to consider is that we have this process where if you guys have an approved query and you find a severe at risk protocol after it's been approved and you let us know, we are more than welcome to upgrade your query. So maybe you have an uncommon query and you find a severe at risk protocol and you report it to them. We are going to re-rank or rescore your query so it could be upgraded from a rare epic or in this case a legendary query. So just be very mindful of that. If you guys have some of you guys have approved queries, so don't be afraid to um, dig deeper through the chain and try to find some actual vulnerabilities and report it to us because we will rescore your query. We're more than welcome to do that. And if you want to do that, just mention that to us in the contribution chain or contribution thread that you have for your approved query. I think that's really it on the legendary query front. I mean, I think the really big requirement is that you find a severe at risk protocol with your query, and uh, obviously, it's really nice that the query is written well, but that's something that you could work with a triager to improve. And certainly, if there's one that has a very high at risk, we are going to make sure that the query works very well, it runs well, um, and so I think that that's the fastest path to a legendary. I know some of you guys are looking for this, so certainly want to support you in any way possible. And if you guys do find a protocol at risk and you can't reach them, um, you could just reach out to us and we can help you. We're not going to expect a fee or anything from that. We certainly have ability to probably contact them if you're not able to. Any questions, Ellen?
No questions in the chat.
Okay, great. Thanks everybody for listening to 45 minutes of me giving you tips and advice. I really hope this helps. As always, you guys are more than welcome to uh, DM me or message us in Discord. I really, really try to be as proactive as possible on there. I also just want to say, really, really, really appreciate you guys' patience on queries that are submitted. I know some of you guys are asking about it. I promise you, we're working around the clock. Um, I certainly am, as well as others, and we're trying to get through every query as possible. So as long as you're just a little bit patient, I promise we'll get to it and we'll get it approved. And I just want to say thank you guys for spending all the time and effort to work on your queries and submit them. And I hope every one of you guys finds valid vulnerabilities and you get on the leaderboard for um, our contest. Well, I think there's only 10 spots on the leaderboard, but I wish the best of luck to everybody here, and we want to support everybody in every way possible. So don't hesitate to reach out. I'll share links and the file at the end of this call, and if you again missed my screen sharing, I'll have the file as part of the shared links, but we'll also post this on YouTube. So you could check back on the portions of code that I was sharing on screen that you weren't able to view. So other than that, anything else, Ellen?
Thank you, Jason.
Thank you guys. Appreciate it. I'm sure I'll talk to you guys soon and have a good rest of the week.
Yes. Bye bye, guys. See you next week.